Let's take a look at Gamma. That's what's the textbook we're using. It's a Year 11 textbook, exercise 12.01. And we're going to do question 18. And we're doing question 18c. I'll put a circle around it. Calculate the length marked x. So we've got this trapezium. We've got a rectangle here. We've got a parallelogram here. And we've got a triangle here. And really all we're going to focus on are the actual triangles here. We're not really concerned with the parallelogram or anything else. Certainly not the trapezium. So let's have a look at that now. So what I'm going to, in fact, this bit at the top here is really totally irrelevant. So certainly for calculating C anyway. So let's have a look at that. And I'm going to redraw, first of all, the triangle at the bottom, this one here, the BCD triangle. Here it is. So here is that triangle, the BCD triangle. There it is. Now, the reason I'm drawing this is because this actually forms part of the rest of the triangle, which is this bit at the top here. So we've got a triangle at the top, triangle down here. We're told that this is 8, this is 15, and the hypotenuse is 17. So the short side is 8, the next shortest is 15, and the longest, of course, is 17, which means that this must be 8, and this must be 15 along the top. Of course, there is our right angle, just as this is our right angle. But what they do is they draw a line going down here at right angles to the base. Now, this has a special name, this line here. It's meant to be an arrow, by the way. This is called the altitude. Now, the altitude of a triangle is if you would take any right-angled triangle. Here's my right-angled triangle. Not well drawn. Not well drawn. There's my right angle. And I take from the apex and I drop a line, a vertical line, at right angles to the base. There's my altitude. So what I've done is I've just taken this here, I've twisted it on its side, and I've drawn it there. There it is. That's that one there, yeah? And I've twisted it on its side, and there it is there. And we're finding x. X is this side here, which is the altitude here. Now let's just fill in some of the details here. The short side is 8. Yeah? The hypotenuse, well, this was the hypotenuse of the bigger triangle, which now, 17, of course, is going to be the base or the hypotenuse of this triangle here. So this is 17. Here we go. And of course, 15 is the side along here, and that's that side along here. So there's 15. But here's the big thing. Here's the important thing. When you create an altitude, you've now created 3 similar triangles. You've got this triangle here, this triangle here, and this triangle here. All those triangles are similar. They all have the same properties in terms of their internal angles, and all of their sides are in proportion to each other. So let's have a look now. This is the shortest side. This is next shortest. This is the hypotenuse. So let's take this little triangle down here now and redraw it. And I'm going to draw it right next to it, in fact. Here we go. There it is. There's my right angle. So that is that right angle there, yeah? Now, we want to find x. Well, x is going to be this side here. So I've taken this one here, and I've twisted it and put it on its side, yeah? So here's x, there's x, yeah? 8, where is 8 on the little triangle? Well, 8 on the little triangle, this is actually now the hypotenuse of that little triangle. 8 is the hypotenuse. There it is. So now I've got x, hypotenuse, and of course this is the shortest side here, yeah? So the shortest side, of course, is this one here. We're not interested in that side. But what we've got now is we've got sides in proportion to each other, which means that this side is in proportion to this one, the same as this is in proportion to this one. Because this triangle here and this triangle here, they don't look very good, by the way, do they? Is in fact in proportion. These are similar triangles. So that 8 there. So what I've done is I've taken this one and I've twisted it round so that this now is on the base and the x is on this side here. All I've done, taken it and twisted around. I've done that, yeah? That's all I've done. All right, so now we've got, let's take a look. So this looks good. So now let's go ahead and solve for x. So we can say 15 is to 17 as x is to 8. Or you could do it differently as well. I'll show you. So 15 is to 17 as x is to 8. Or you could have said, let's do it differently. You could say x is to 15 as 8 is to 17. Let's try that. X is to 15 as 8 is, x is to 15 as 8 is to 17. Yeah? Looks different, but it's exactly the same, as you will see in just literally moments, yeah? Oh, did I do that correctly? X is to 15. Oh, wait. What did I just do? I said x is to 15 as 8 is to 17. Oh, I did do that. Okay. All right. All right. So that looks good. In fact, sorry, it's late. My brain's not working. All right. So let's calculate this. Let's cross multiply and make x the subject. So in fact, I'm just going to multiply everything by 8 here. So x is equal to 15 times 8 over 17. Let's do the same thing over here. X times 17, that's going to be 17x is equal to 15 times 8. So x is going to equal 15 times 8 divided by 17. Oh, look, I get exactly the same thing. Well, what is that same thing? So let's go ahead and calculate this out now. So I get 15 times 8 divided by 17. 15 times 8 divided by 17, and I get 17.0588. X is equal to 7.0588. And I'm just going to round that. That's equal to, let's do it to 2 dp's. So 7.06, and I'll put centimeters, and I'll put 2 dp. I should have left a bigger gap here, by the way, because we always leave a gap in between the units and the number. But that ultimately is my answer.